Hello all. In today's session we will talk about backpropagation algorithm. So to learn this backpropagation algorithm you should have a good idea of what forward propagation is and what gradient descent algorithm is, and these were the two topics which we have already studied in the previous sessions. So before moving on to this backpropagation algorithm, the rule which will be used here is called as chain rule, one of the derivative rule which is used in backpropagation to update the weights and biases, that is to find the optimized values of weights and biases such that the neural network which we are training will predict the accurate output value. So this chain rule is a formula for calculating the derivatives of functions that are composed of functions inside other functions. It is also called as outside-inside rule. Given this equation, derivative of f of g of x is nothing but the derivative of the outside function which is f of g of x multiplied by the derivative of inside function which is called as g of x. This can be implemented better understood in the diagram here. If I want to find the derivative of e with respect to x, in between I have two other parameters b and a. So I will find derivative of e with respect to b multiplied by derivative of b with respect to a multiplied by the derivative of a with respect to x, and so on. So this chain rule is implemented in backpropagation algorithm, and we are going to do this bunch of multiplications, nothing but called as partial derivatives, so that we have the optimized values of weights and biases. So let me first numerically explain what backpropagation algorithm is using a simple training example. For example, I have a data set of age and experience, and based on these age and experience I would like my machine to predict the salary in per annum. So I have the data set values as 25, 2 and 2, 33 and 3 and so on. For example, I have 100 data points here, and the idea here is, given the value of x1 and x2, I want my machine to predict the value of y. So let me draw the diagram of neural network here. As it is a very simple neural network, I will consider this to be as x1, x2 as my input. This is my output layer, which is nothing but y hat, which my machine will predict. Let me take only one hidden layer here to make more easy calculations in this session. So I'll connect x1 and x2 to both these nodes of hidden layer, which will come up with the predicted output y hat. So let y11 be the first layer weight corresponding to x11 and w12, and this is 21, 22 respectively. Let the bias here be b11 and the bias here is b12 and the bias here is b21, and the corresponding weights here are for the second layer w11 and for the second layer w12 respectively. For example, this is my artificial neural network for this data set given. What we are doing here is we are performing backpropagation algorithm to find or to minimize the error, that is updating the weights and minimizing the errors here. So we have few steps involved to be followed in backpropagation algorithm. The first step involved is take some random values of w and b. Here we have many initialization methods. The first initialization method is take some random value of w and b. Any integer value can be taken. And the second initialization method, what we take is we take the weight value as 1 and initialize b with a 0 and so on. For this example here, I will take this initialization method where I will take all the weight values as 1 and all the biases as 0. Taking this weight value and bias value as 1 and 0 respectively, I will perform the feed forward propagation and calculate the value of y hat, which will be my predicted output. So taking this diagram, I can write y hat as, let me write the outputs here. Let O11 be the output here and let O12 be the output here, and here let the output be O21. So y hat is nothing but what? O21, which can be written using the equation as, using weighted sum as O11 into W11 here. O21 is O11 into W11 plus O12 into W12 of second layer plus bias. Wx plus B I am writing here. Right? Now, I'll perform the forward propagation and calculate this predicted weight value. This predicted weight value will be compared with the true value. For example, if I take this random training example to train my machine, and I would like my machine to predict for the given value of x1 and x2 as 25 and 2, and I got predicted value as somewhere 7 and the true value is 2. In the second step, I'll select the error. As it is regression analysis, I will select mean square error, whose formula is given as loss function is equal to y minus y hat whole square, and here 2 minus 7 whole square, I will get very huge loss function here. I would like to reduce this loss function. So in the third step, I will backpropagate from output layer to the input layer, updating all the weights and biases to minimize this error function. How many weights I have? I have 6 weights here and 3 biases here. So I will update all these 9 parameters by backpropagating. And to update these 9 parameters, I will make use of gradient descent algorithm with formula. If I would like to update weight, I will write W is equal to W old minus eta times of slope of that weight, that is dou L by dou W old. This is the formula which I will be using. So these steps we will use in this numerical example. So what will I write here is, I'll write the equation again. O21, which is nothing but O11 W11 2 plus O12 W12 plus B21. So what we are doing here, we are varying the loss function by varying the output value, and this output value can be varied by varying all these 5 parameters which are not constants. So I can vary y hat by varying O11, by varying W11, by varying O12, W12, B21. This is a hierarchy what I have formed here, because to vary this loss function, I will vary y hat. To vary y hat, I need to vary all these 5 parameters. Now, coming to this O11, how will I vary this O11? You can look into this. What is O11? O11 is equal to output of the first node of hidden layer, which is x1 into W11 plus x2 into W21 plus B11. So how will I vary O11? By varying W11, W21 and B11. I will not vary x1 and x2 because these are constants. So O11 can be varied by varying W11, I have W11, W21 and B11. So on, I will write the hierarchy. Now, I'll start from the output layer and reach the input layer. So let me take the first weight which I would like to update as W11. So I will write dou L by dou W11. That is, I am updating the value of W11 with respect to the loss function. Now, how is this loss function? I am varying WL with respect to what? Where is that? This is 2 and this is 2. So I am varying or reducing the loss function by varying W11. This is hierarchy which I will follow. So I cannot vary loss function by varying W11. I have a parameter called as y hat in between. So using chain rule, I write dou L by dou y hat into dou y hat by dou W11 into, So dou L by dou y hat is nothing but what? partial derivative of loss function with respect to y hat. So loss function is y hat whole square. I'll find the partial derivative of this with respect to y hat. I'll get some value. And what is dou y hat by dou 1 1? I'll find the partial derivative of this with respect to dou 1 1. I'll get the value. I'll substitute these two values. I'll get the value of dou L by dou W 1 1 square with some numerical value I'll get. For example, I got here as 2. This is what? Variation of loss function with respect to W11. So I will substitute this in the equation of W11 new. I'll find new value because I'm finding new value of what? This one. So W11 square of new is equal to W11 of old, or simply I write W11 minus eta times learning rate times of dou L by dou W11. So this old value was what? 1 minus 0.001 times of this value what I got, for example here as 2. I'll substitute, I'll get the new value of my first weight. That is the weight which is close to the output layer. Next I will take this weight, I'll update this weight. Taking this hierarchy into consideration, I'll update this as dou L by dou y hat into dou y hat by dou 1 2. Substitute all the values, I'll get the updated weight. This process I'll continue till I reach the input. Now what if I would like to update this value W11 dash? Do I have L related to W11 here? Yes. How? I have the L related with y hat related with O11 which is related to W11. So I will write dou L by dou W11 which is the first layer weight is equal to dou L by dou y hat multiplied by dou y hat by dou here O11 dou O11 multiplied by dou W11 dash. This we know. This also we know. Now how do I find the partial derivative of this? We know the equation of O11 as x1 into W11 plus x2 into W12 plus B11. So I'll find the partial derivative of this with respect to 1 I will get this as x1. Substituting all these, I'll get dou L by dou W11. Now I will substitute in this equation, I'll get W11 minus eta times of dou L by dou W11 dash. Okay, this value is 1 minus this value is 0.001 multiplied by dou L by dou 1. That is the value what we get here. I'll get the new value of my weight. In this way, we have reached the input layer where all my 9 values got updated. Similarly, I can update the value of biases also from this hierarchy. How will I update B11? For example, the weight which is very close to my output layer is B21. So I will update this B21 as dou L by dou y hat multiplied by dou y hat by dou B21. Right? So in this way, I will be updating all the 9 weights. So these are the steps involved. First, perform forward propagation, taking some random values of weight and bias, obtain the predicted output, select the error function depending upon the analysis. If regression analysis, MSE. If classification analysis, I'll go for cross entropy, and then perform the gradient descent to update the weights using this formula. W new is equal to W old minus eta times. Here alpha also can be represented for error rate. Now backpropagation is propagating back by finding the derivative at each layer and updating the corresponding layer weights and biases till we obtain the minimum error. So this equation is applicable if I have only one weight. What if I have many number of weights as I have shown in the previous numerical example? It makes use of chain rule where I'll go one layer after the other finding the partial derivative and finally reach the input layer. So by applying the chain rule, this you can see that I got the partial derivative of all the weights corresponding, and finally I'll obtain the loss function. Different loss functions, loss values I'll get and wherever the error is minimum, that weights and biases, updated weights and biases will be finalized. So this is the end of our session. Thank you.